Now let's try to tie this all together by looking at a demo of text editors, writing code, and deploying our code. In this demo, we're going to use SSH to remote to the device. Then we'll write a little bit of code to control a real-life IoT device directly. Then we'll write the code locally and deploy it to the device. In the process of doing all this, you'll see a couple of different text editors in action. Let's get started. The first thing we wanted to do was SSH to our device, so we'll type SSH root at, my device happens to be called TweetMonkey, use the mdns.local, and that jumps us into the device. You'll notice that I am using a key to avoid having to type in a password. I've landed at my home directory, and the first thing I want to do is jump right back into our node REPL, and in that node REPL, you saw that we were able to do typical JavaScript-y things like that. And in addition to that, I do want you to know that you have the ability to require, that's a node concept, you have the ability to require the MRAA library from right here. And if I do that from right here on the REPL, we'll actually see the returned object, the object that comes back from that module requirement. That's it. You don't really need to know what all of that means, but it is assuring to see that happen and know that we have good access to the MRAA library. Let's go ahead and actually bring that MRAA library into a local variable because we're going to use it. And the first thing we'll do is we'll create a variable, a JavaScript variable for pin13, something that we'll call pin13. Now, in case you're not aware, most IoT devices, most boards, give you an LED on the device to represent pin 13. The pin itself actually still works as a digital output pin, going high and low, but it also gives you that visual representation, which is extremely handy for being able to tell whether or not things are even working. And it's always very satisfying just to see a blinking LED and knowing that you're doing everything right. So let's create ourselves a local variable, calling it pin13 because that's intuitive, and we will instantiate a new MRAA GPIO. This is just the way the API works. You do that by calling your MRAA object, the GPIO method, passing in the pin number, and there you have pin 13 is actually defined. It's not much of an object yet, but that's okay. Now we need to set the pin direction by calling the dir method and passing in a MRAA constant, which is dir out. This is telling it that we're going to use pin 13 as an output pin, even though it can go, technically it can go both directions. So the direction has been set, and now we have the ability to say pin 13 write 1. And I just saw the LED come on this board. Then I can pin 13 write 0, and I just saw that LED go off. So I am directly controlling that LED. Now this is not the way that you want to write code, jumping into the node REPL manually. It takes a human being to do that and writing directly to the MRAA library. So we're going to start to make this easier. Let's jump out of the node REPL. Here we are back to our home directory. And let's do a little bit of dev on the device. I'll go ahead and make a directory called IoT, switch into it. It's obviously empty for now. Let's go ahead and touch a file called app.js, so that exists now. And let's VI that file. Here we're met once again with that issue that I showed you the workaround for, where VI says that it cannot read user input, and the only way around this is for us to jump out of our connection altogether, and instead of SSHing to the MDNS name, we have to SSH to the IP address. I don't happen to remember that, so we'll ping it. There we go. Comes back pretty quickly for us. And here we are back into the IoT folder, vi app.js, and it's working. Now what we want to write in here is basically the same code that we put into the node REPL just a second ago. We want to var MRAA equals require MRAA. Then we want to var pin13 equals a new MRAA GPIO 13. Pin 13's direction should be set to MRAA.dir out. And then I can pin 13 write high, and just for visual effect, let's say we want to do a set timeout, writing a function in which we say pin 13 write 0, and we want that to occur after 2 seconds. There we go. That should work. So now we have an app.js that looks like this, and we want to run that. We simply node app.js. And I saw the light come on, and 2 seconds later I saw the light go off. So in fact, that's working, doing development on the board. But now let's do a little bit of local development. So we'll jump off of the device, and now here we are back at my console. On my console, I'll go ahead and create a directory called IoT Local. That directory exists now, and I'm going to use Visual Studio Code, which at the command line is just code, IoT Local. Now, the nice thing about code is that if I code some file, it will launch that file in code. But if I say code and I specify a directory, I can specify this directory by just doing a dot. Or in this case, I'm going to say a local directory, this IoT local directory here. And what that's going to do for me is it's going to open Visual Studio Code with that as the, basically as the project folder for this project. So there is recognition of a project folder within code, even though primarily it's just working with files. Now, if I come over here to the left, you see that it's got this concept of the folder there, and it gives me the opportunity to create a new file. So this is a very nice working environment. Back to app.js. So let's go ahead and write this. Now, you've seen me write this a few times before, so I will not make you watch me type again, but all we're doing is bringing in the MRAA library, creating a pin 13, setting its direction. Now I'm going to do things just a little bit different. I'm going to create a local variable called state and set that to false to start with. And then I'm going to create a function that will toggle this state and the LED as well. So this function is going to first take the state and set it equal to not state. Then it's going to say to pin 13 that you should write the value of state. And finally, we should call recursively by setting timeout and calling toggle. And we'll say 500 milliseconds later. So this light's going to blink rather fast, rather quickly. It's going to blink it's going to come on in a half a second and then off in a half a second. So it'll blink at about once per second. Okay, so let's go ahead and save that. Now, if we go look at that on the local directory structure, and what I've done is I've set my directory structure up side by side here, so that on the right, let me just clear these so they make good sense to you. On the right, we've got the remote machine, the device, and on the left, we've got my local machine. Now, inside this IoT local folder, I have the app file, and it's off the screen, can't see that. But let's go ahead and cat out app.js, and you can see that that's the project that we just wrote. Now on this machine, let's go ahead and I've already created a file called IoT local, but actually to make this authentic, I'm going to go ahead and wipe that out. So I'll make a directory called IoT local. This is where we want this to deploy. Sometimes this deployment process is quite manual and you have to get to the device and create a folder to even copy it in there, unless you devise a way to remotely create a folder, copy the files into it, and then even maybe do something more advanced like execute node and start that process going. So now I've got this IoT local folder and we can COT into that. There's nothing in it right now, as you can see, absolutely nothing in that folder. But from local, we can SCP, copying app.js as root to our device, tweetmonkey.local, we want it to go to the home directory and inside of IoT local. Let's make that so. It's not going to prompt me for a password because I'm already set up. And now if I go to my remote device, you can see that app.js exists, and that file is everything we want it to be. Let's go ahead and node app.js, and it didn't work because there's one thing that I forgot. I created this wonderful function and never called it. I need to kick it off. I need to kick it off with a function call. So I'll switch back to local. This will kind of demonstrate this this production cycle that we have to go through, this development cycle rather, where we need to modify things, and then we need to deploy them. So I'll change that, save it, flip over to my local directory structure. I can usually recall these commands. So there's that one. It's going to copy right over top of it, and then I'll flip over to the remote window and once again try node app.js. And this time I'm getting myself an error, and that error is a typical one. I have a variable, a JavaScript variable called state that is a Boolean value because I initialized it with false and I kept flipping it to its inverse logical value, and yet pin13 write is looking for a 1 or a 0. Well, that's an obvious fix. When I do my write, I can say state, and if that's true, this is using an immediate if function, if that's true, then 1, and if it's false, then 0. Well, that fixes it. Once again, we'll go recall this. And this becomes kind of a typical cycle where you change something, and then you flip over and you execute it, and finally you have it working. And now I'm looking at my board, and the LED light is flashing. Every 500 milliseconds, the state is toggling. So that does it for this demonstration on writing and deploying code the manual way.